Today we are introducing you hydrometer analysis test. Hydrometer analysis is the procedure generally adopted for determination of the particle size distribution in a soil for the fraction that is finer than number 200 sieve size, or 0.075 millimeters. The lower limit of the particle sizes are determined by this procedure is about 0.001 millimeter. In hydrometer analysis, a soil specimen is dispersed in water. In a dispersed state in the water, the soil particles will settle individually. It is assumed that the soil particles are spheres and the velocity of the particles can be given by Stokes' law. If a hydrometer is suspended in water in which soil is dispersed, it will measure the specific gravity of the soil water suspension at a depth L. Equipments: hydrometer, mixer, 2 1000 cc graduated cylinders, thermometer, constant temperature bath, deflagrating agent, spatula, beaker, balance, plastic squeeze bottle, and distilled water. Our procedure is used when more than 90% of the soil is finer than number 200 sieve. So step 1. Take 50 grams of oven dry, well pulverized soil in a beaker. Step 2. Prepare a deflagrating agent. Usually 4% solution of sodium hexametaphosphate, which means also calgon, is used. This can be prepared by adding 40 grams of calgon in 1000 cc of distilled water and mixing it thoroughly. Step 3. Take 125 cc of the mixture prepared in step 2 and add it to the soil taken in step 1. This should be allowed to soak for about 8 to 12 hours. Step 4. Take a 1000 cc graduated cylinder and add 875 cc of distilled water plus 125 cc of deflagrating agent in it. Mix the solution well. Step 5. Put the cylinder in a constant temperature bath. Record the temperature of the bath T in Celsius. Step 6. Put the hydrometer in the cylinder and record the reading. Also observe the meniscus correction. Step 7. Using a spatula, thoroughly mix the soil prepared in step 3. Pour it into the mixer cup. Note, during this process, some soil may stick to the side of the beaker. Using the plastic squeeze bottle filled with distilled water, wash all the remaining soil in the beaker into the mixer cup. Step 8. Add distilled water to the cup to make it about 2/3 full. Mix it for about 2 minutes using the mixer. Step 9. Pour the mix into the second graduated 1000 cc cylinder. Make sure that all of the soil solids are washed out of the mixer cup. Fill the graduated cylinder with distilled water to bring the water level up to the 1000 cc mark. Step 10. Rubber stopper on the top of the cylinder. Mix the soil water well by turning the soil cylinder upside down several times. Step 11. Put the cylinder into the constant temperature bath next to the cylinder described in step 5. Record the time immediately. This is cumulative time T equals to 0. Insert the hydrometer into the cylinder containing the soil water suspension. Step 12. Take hydrometer readings at cumulative times T equals to 0.25 mins, 0.5 min, 1 min, and 2 min. Always read the upper level of the meniscus. Step 13. Take the hydrometer out after 2 minutes and put it into the cylinder next to it. Step 14. Hydrometer readings are to be taken at time T equals to 4 mins, 8 mins, 15 mins, 30 mins, 1 hour, 2 hours, 4 hours, 8 hours, 24 hours, and 48 hours. For each reading, insert the hydrometer into the cylinder containing the soil water suspension about 30 seconds before the reading is due. After the reading is taken, remove the hydrometer and put it back into the cylinder next to it. General comments. A hydrometer analysis gives results from which the percent of soil finer than 0.002 mm in diameter can be estimated. It is generally accepted that the percent finer than 0.002 mm in size is clay or clay size fractions. Most clay particles are smaller than 0.001 mm and 0.002 mm is the upper limit. The presence of clay in a soil contributes to its plasticity. Extras will be added at the end of the video. Thanks for watching us. Please share it with your friends, and if you did not subscribe to our channel, please do it now.